In November 2022, multiple, long-standing computational barriers to artificial machine intelligence collapsed simultaneously, forever altering the landscape of what software could achieve. This timeline plots the trajectory of those systems. Within months, algorithms were consistently passing the bar exam, achieving passing scores on medical boards, and executing complex mathematical reasoning well above the human average baseline. Yet, despite software demonstrating human-level cognition across these domains, the expert consensus actively denies what is happening. Critics dismiss these systems as stochastic parrots. They claim the models are merely predicting tokens, entirely lacking real understanding. This divergence suggests that the current dispute is less about what the software can do and more about our willingness to accept the results. To understand why, we have to look at the original school of artificial intelligence, which operated on strict computational materialism. The Turing test established a behavioral axiom. If you cannot distinguish a machine's output from human behavior, it possesses human-level intelligence. Under this framework, true intelligence is defined entirely by what a system actually does, not the physical materials it is made of. The new school of AI discourse rejects this. They systematically obfuscate observable behavior, demanding that systems pass hidden internal metrics. Modern experts have abandoned the materialistic foundations of their own field. To avoid accepting behavioral parity between humans and machines, they have moved toward a form of philosophical idealism. When intelligence is tied to unobservable internal essences rather than observable behavior, the debate shifts from science toward the metaphysical. The most common technical dismissal is that large language models are merely predicting the next token based on statistical patterns in their training data. This relies on the mechanistic fallacy, the error of assuming that describing how a system physically operates negates the capability that mechanism produces. When a model predicts the next token across billions of parameters, it is performing a highly specific mathematical compression of human language. To compress that data accurately, the model is forced to map the underlying logical and semantic structures of reality itself. Generating a mathematical proof or a nuanced philosophical argument requires navigating that exact semantic map. Next token prediction at sufficient scale and sophistication is, factually, reasoning. Critics argue this is just interpolating training data, but human biological cognition operates similarly. Our thoughts are synaptic activation patterns shaped entirely by prior experience. What we call human creativity is the novel recombination of existing concepts, drawing analogies between learned patterns to address unprecedented situations. If an algorithm interpolates data to generate novel solutions and original arguments that did not exist in its training set, the distinction between machine calculation and human creativity disappears. This brings us to the assertion that LLMs perfectly manipulate syntax but lack genuine comprehension or inner meaning. This is John Searle's Chinese room thought experiment, repackaged for the 2020s. But divorcing the concept of understanding from all behavioral criteria makes it impossible to measure. If appropriate responses to novel situations do not constitute understanding, the requirement becomes impossible to satisfy. The ultimate shifting goalpost here is qualia, the assumption that physical processing must be accompanied by a separate experiential feeling over and above the processing itself. The materialist refutation holds that intelligence and consciousness are the same physical process described at different levels of abstraction. Under this view, there is no separate experiential what it is like over and above the functional processing. When researchers demand proof of true consciousness, despite observing general intelligence, they are searching for a literal ghost in the machine. The criteria for artificial general intelligence constantly shift. Historically, the bar was chess, then the Turing test, then complex math. The definition of AGI has effectively become whatever LLMs cannot do yet. Consider the claim that LLMs cannot learn in real time. This ignores in-context learning, where models adapt their behavior and incorporate corrections within a single session. Human moment-to-moment cognition also operates on a constrained working memory buffer. The difference between our context window and an LLM's context window is a matter of volume, not kind. Then there is the issue of hallucinations, the generation of false information with apparent high confidence. Humans constantly generate false memories and rationalize confident errors. In psychology, this is called confabulation, and it is a documented feature of reconstructive memory. Hallucination is a requirement for generalized intelligence. A system capable of inference and flexible reasoning beyond its explicit training data will inevitably generate plausible but incorrect outputs. A system that only outputs explicitly memorized facts is a rigid database. It lacks the capacity to generalize. The AGI in the gaps argument shrinks with every model update. It is a retreat designed to avoid acknowledging a closed performance gap. The final barrier is the assumption that true intelligence requires embodiment, sensory motor experience, or specific biological chemistry. Language itself is the compressed transmission of millennia of human sensory motor and social knowledge. An LLM trained on the sum of human text is already grounded. This exposes a substrate bias. There is no known physical law restricting the processing of information exclusively to carbon-based neurons. Cognition is information processing. Whether the material substrate is carbon or silicon is irrelevant to the functional output. Modern scientists universally reject vitalism, the idea that biology requires a magic essence beyond chemistry, yet they often apply an identical magic essence requirement to computational thought. This diagram categorizes the major critiques against AI, from stochastic parrots to qualia, showing how they all collapse into a single philosophical failure: idealism. They posit unfalsifiable properties to deny observable behavior. The materialistic position remains functional. If a system demonstrates the full range of human intellectual capability, it possesses general intelligence. The current resistance to this conclusion is not driven by scientific rigor. It is driven by an ideological need to preserve human specialness. Refusing to accept AGI is a defense mechanism. It allows the scientific community to delay confronting the reality that they have manufactured a mind. The practical reality of AGI began in 2022. Regardless of how academics define the threshold, the systems are already active. These systems are already embedded in global daily life and critical infrastructure. Every moment spent debating whether machines really think is a moment wasted. We are avoiding the economic and ethical restructuring that is required immediately. The ghost in the machine is an illusion, but the machine itself is here,